Hi, I'm James Bailey from Transmille, and I'd like to talk about the effects our test leads make on our measurements, particularly with reference to the insulation of the test leads on making high value resistance measurements. Now here you can see we've got a high value resistance standard, 100 mega ohm resistance standard, connected to a little HP 34401, measuring the resistance on a 2-wire resistance, and it's coming out at about 100.1617, jumping around a bit, mega ohms. Now, using a different set of leads, this is just leads made from the typical extra flex cable, silicon cable connections. And now we have a reading of 97.8 mega ohms. Quite a considerable difference, 2 to 3% difference on the original reading, just because we've swapped our leads. Now, I'm going to take a look at measuring what the insulation resistance of these leads are. Now this is way higher than the HP can read, so I'm going to use the electrometer function of the Transmille 8081 to measure what these leads actually are. I can just lay them down there. And in fact, these leads are coming in at about 3.8 G ohms for, it's jumping around a bit, for that insulation resistance. And if I squash them together, the resistance is changing all over the place, indicating that the actual plastics that are insulating the two conductors are not operating very well indeed, making any kind of measurement you make with these invalid for a high value resistance. I've got another set of typical leads here, slightly more professionally made set. I've coiled them all up kind of neatly, which actually makes the whole thing much worse because there's much more of the black lead in contact with the red lead. But if I just plug them in and lay them down, there we go. But we're much higher now, but still looking at 190 G ohms of resistance. Now I have a little table coming up next to show you the effect of insulation resistance of the test leads, the error they will produce measuring a certain value resistor. So as we can see from this short demonstration, getting the right leads for measuring high value resistance is absolutely crucial. And the standard extra flex plastic leads are just no good for it at all. The next type of lead that you can use is the coax lead. Now that's pretty good, standard coax, not too bad. And best of all, if your budget stretches this far, is to the PTFE insulated leads, which offer the best performance. Ideally, to cut down noise, which will be covered in another video, screen leads should be used. And also, of course, as per the previous video, thermals are not really that important at this point because often resistors of high value are being measured with usually quite a high voltage across them. So small thermal voltages in the connections at the end is usually not the problem. It's more insulation of the test leads themselves, loading the true value down so you get a reading that's lower than you should do and possibly more unstable, because as we've seen, the lead resistance can change quite dramatically and very quickly with humidity and pressure. You get two of them knotted together, can make quite a big difference. So that's all on high value resistance measurement.